The elements of the periodic table are defined by the number of protons in the atomic nucleus, the atomic number. So how can there be gaps for new elements? Sure, we could keep adding protons at the top end of the periodic table, but those seem to be hopelessly unstable and so hardly useful for building warp drives. But the fact is, gaps in the periodic table did exist. Atomic numbers that did not seem to appear naturally. And it may be that the current upper end of the periodic table is just another such gap, beyond which there may exist an island of stability containing useful elements never before encountered. To understand the possibility of new artificial elements, let's start with the story of the first artificial element. We begin all the way back when Mendeleev figured out the periodic table. He arranged the known elements according to their atomic weight and noticed periodic recurrences of chemical properties as atomic weight increased. We now know that chemical properties depend on the number of outer shell or valence electrons, which increases by 1 every time you add a proton to the nucleus, until the shell fills up and you start over, filling the next shell up. Although he didn't know about protons, Mendeleev did notice gaps in his periodic table. He correctly interpreted these as 4 elements that had yet to be discovered. He was even able to predict many of their properties. Over time, 3 of these elements were discovered, and the gaps were filled with scandium, gallium, and germanium. But there remained a missing element, right between molybdenum and ruthenium, which we figured out had to correspond to a nucleus with 43 protons. For 7 decades, chemists searched for element 43, but it was nowhere to be found in nature. It was eventually discovered, but not in nature. In 1937, Italian physicist Emilio Segre got hold of some molybdenum foil that had been part of Ernest Lawrence's newly invented cyclotron particle accelerator. The foil had been rendered radioactive in the accelerator, and Segre and his colleague Carlo Perrier were able to show that some of the molybdenum had gained a proton, transmuting it into element 43. They named the new element technetium after the Greek word for art or craft, so in a sense, its name means crafted element. It's a silvery grey metal with chemical properties somewhere between manganese and rhenium, the elements above and below it on the periodic table,